Welcome dear students. In this video we will discuss about curvilinear motion. So let us start. So whenever a particle move along a curve as shown in this figure, or whenever you hit ball in a golf or in cricket or in any other sports, so it will most likely move in a curved path. So a particle moving along a curve other than a straight line is in curvilinear motion. Now consider this figure. So suppose the initial position of the particle is P and the position vector of the particle is this OP, and consider the particle moves from P to P dash, and the time delta t. Okay, so initially the particle is at P and the position vector is R, then it moves to position P dash, the position vector is R dash, and this delta R is the change in the position of the particle. Okay, you can calculate the velocity, and velocity is simply change in the position of the particle, that is delta R, and divided by the delta t, and this limit delta t tends to 0. So when this limit tends to 0, we can write dr by dt. So in this way you can calculate the velocity of the particle in curvilinear motion. And if you want to calculate the speed, then you have to simply put the distance in the numerator instead of displacement. So distance can be greater compared to displacement, because displacement is the minimum distance, okay, while the distance is the actual path traveled by the particle. So if you are taking the actual path, then we will be getting the speed, and this speed is a scalar. It only has the magnitude, and while this velocity is the vector, it has both magnitude as well as direction. Now consider you want to calculate the acceleration of the particle in a curvilinear motion. So that is very simple. Suppose the velocity at when the particle is at p is v, and when the particle moves to point p dash is v dash. So similar to the velocity, the acceleration can be written as limit delta t tends to 0 del v by del t, which is equal to dv by dt, and this is the instantaneous acceleration. And this acceleration vector is not tangent to the path, though velocity is always tangent to the path of the particle, but this acceleration vector is not tangent. Okay, now we will see the rectangular components of velocity and acceleration. So suppose your particle is having the position vector r, okay, and we know that we can express any vector in components of x, y, and z. So we can denote this r as xi plus yj plus zk. Okay, now if you want to find the velocity, what you need to do, you simply differentiate this equation. So then velocity will be v is equal to dx by dt I plus dy by dt j plus dz by dt k. You can also write in this form x dot I plus y dot j plus z dot k, or you can also write in this form vxi plus vyj plus vzk. Now in order to find the acceleration, what you need to do, you simply differentiate this equation again. So acceleration is dx d2x by d2 square I plus d2y by dt square j plus d2z by d2 square k. Or you can also write x double dot I plus y double dot j plus z double dot k. Or you can also write in this form axi plus ayj plus azk. So they are one and the same. All these things are one and the same, but just different notations. Okay. So in different books you can find different notations. So please don't confuse. All these notations are same. Now these rectangular components are useful in many situations. For example, a motion of a projectile, because in the motion of a projectile, the acceleration can be integrated independently, means the acceleration of the particle do not depend on any other direction. So suppose this is your projectile and it is thrown with initial velocity v naught, and this is the path of this particle, and these are the velocity components vx naught and vy naught. So we can write acceleration in x direction is 0 because there is no acceleration. In the y direction we have the acceleration due to gravity, and again in the z direction the acceleration is 0. And these are the initial conditions. If you suppose this as origin, then x naught, y naught, z naught, they are 0. And these are the initial velocities of the projectile. So in the motion of a projectile, these rectangular components are very, very effective. And from this you can easily integrate, and you can obtain the values. You simply need to integrate this equation twice, then you will obtain x. Similarly, you can integrate this equation twice, then you will obtain y. Integrate this equation twice, then you will obtain z. So after integrating twice, we get this velocity as this, and position vector you can find like this. Okay, and since this problem is 2D, so there is no z, so it is 0. Again, this rectangular components are helpful when motion is in horizontal direction, is uniform. So motion in horizontal direction is uniform, then you can use these components. Now if motion is in vertical direction is uniformly accelerated, in that case also these rectangular components are effective. And another situation where you will find these rectangular components very, very helpful is where motion of projectile could be replaced by two independent rectilinear motions. So suppose this is the projectile. So if you replace its motion is by a horizontal motion and by a vertical motion, means you replace the motion of projectile in horizontal as well as in vertical direction separately. So in that case also this rectangular components are very, very useful. Let us do one sample problem. So this is the problem of projectile. Projectile is fired from the edge of a 150-meter high cliff. So this is the cliff. Its height is 150-meter, and from this position you are firing this projectile with a velocity of 180 meter per second, and this is the angle with the horizontal. Okay, now what we need to find? We need to find the horizontal distance, means how much this distance is, which is covered by the projectile. And second thing is the greatest elevation. So how much is the greatest elevation reached by the particle? Okay, so how we will proceed? This is the solution strategy. Consider the vertical and horizontal motion separately because they do not depend on each other. Then apply the equations of motion in y direction, apply equations of motion in x direction, determine time for projectile to hit the ground, and for this you can use the horizontal distance, and maximum elevation occurs when the velocity in y direction is 0. Okay, so you can use this point. The solution. So these things are given: initial velocity 180, and this y naught is 150. Acceleration we know, and acceleration in x direction is 0. So these things are given to us. So first we consider the vertical motion. So vertical motion is uniformly accelerated because acceleration due to gravity is acting in the vertical direction. So this is the equation. Vy is equal to Vy naught, because this is the velocity, so we need to find its vertical component. So Vy naught is 180 sine 30. Okay, because in the horizontal direction we have cos 30 component, in the vertical direction we have sine 30 component. So this is the initial velocity in y direction, and these are the equations of motion for uniformly accelerated motion. We already know this. So Vy is equal to Vy naught plus 80. You simply put the values. Y is equal to Vy naught t plus half a t square, and Vy square is equal to Vy naught square plus 2ay. So these are the three equations. Okay, and again similarly we will write the equation of motion in the horizontal direction. Okay, so suppose we choose the positive direction in this. So in the x direction, initial velocity is this cos component, and we only have this equation: x is equal to vx naught t, because acceleration is 0. So we have x is equal to vx naught t. Okay, and from this you can calculate the x is equal to 155.90. Now let us now move further to the solution. We know that the projectile will hit the ground at this location, and this is minus 150 meter from the origin. Okay, so we can use this. We will put this value in the equation of x, in the equation of y. So y is minus 150. So now in this equation we only have t as unknown, and this is a quadratic equation. So when you solve this equation, the t comes out to be 19.91 second. That means after 19.91 second, this projectile will hit the ground. Now we can calculate this distance from the equation for x, which is equal to x vx naught t. So by putting the value of time, we can obtain this x, which comes out to be 3100 meter. Now we know that the maximum elevation occurs when Vy is 0. So in the equation of Vy, we put this as 0. And now the only unknown is y, which comes out to be 413 meter. So but this elevation from O, if you want to find the maximum elevation from ground, then you need to add 150 meter, this distance. So after adding this distance, the elevation from ground comes out to be 563 meter. Okay, so this is the maximum elevation of the projectile from the ground. So this is the complete solution. So this is how you can solve these type of problems. Thanks for watching. Have a nice day.